What's up, Rustations? Welcome back to Let's Get Rusty. If you haven't already, make sure to get your free Rust cheat sheet by heading over to letsgetrusty.com/cheat sheet. Today we're starting a series on idiomatic Rust. Specifically, in this video, we'll talk about constructors. With that said, let's get rusty. Imagine we were implementing a Rust blog. Here I've created a new cargo package called Rust blog with two crates, a binary crate, which is empty for now, and a library crate. The library crate has a user struct, which represents users on the blog website, and a role enum, which represents user roles. A user has two fields, a username and a role. Let's create a new user instance in our binary crate. First, we have to import user and role. In main, we'll create a new variable called user1. Rust does not have built-in constructors like languages such as C++. There's only one true way to create a new instance of a struct or enum, and that's by specifying the struct or enum name and then initializing all of its fields. Now, this works for simple cases like we have here, but let's see what happens if we add a private field to user. We'll add a new field called ID, which is going to be an unsigned 32-bit integer. Notice that ID is not prefixed with the pub keyword, meaning that this field is private. If we go back to main.rs, you'll see that we get an error. Remember that when creating a new instance of a struct or enum in Rust, we must initialize all fields, and in this case, we're not initializing ID. Let's try initializing ID to 1. Now we get another error saying that we can't initialize ID because it's a private field. We want to keep ID private because we don't want it to be set manually. Instead, it should be automatically generated. To get around this error, we can follow a Rust convention by creating an associated function on the user struct called new, which will return a new instance of user. New acts as a constructor function. It takes in arguments and constructs a new instance of self, which in this case is the user struct. Because new is defined on the user type itself, it has access to private fields such as ID. Another benefit of using this convention is that we can set default values. In this case, we're setting role to creator. Before moving on, let's make sure ID is randomly generated. To do that, we'll add a dependency on the rand crate. Then we'll go back to lib.rs and import the rand prelude. And finally, we'll use the rand crate to generate a random ID. Now let's go back to main and use this function. We successfully constructed a new user. Let's print out user1 to see what values we got. User1 has a random ID, the username we passed in, and role is defaulted to creator. Another benefit of using this convention is that we can do some work prior to returning a new instance. For example, before creating a new instance of user, let's say that we want to check that the username passed in isn't already in use. The first thing we'll do is change the signature of new. Instead of returning self, we'll return a result type. Then we'll need to wrap the returned instance in the OK variant. Finally, we'll check if the username passed in already exists, and if it does, we'll return an error variant. Because this is just an example, we'll simply check if username is equal to testuser123. Next, let's talk about default constructors and the default trait. The Rust standard library has a trait called default, which when implemented on a type gives useful default values. Let's implement the default trait for user. The default trait requires us to implement one method called default, which takes no arguments and returns an instance of self. When creating a default instance of user, we still want the ID to be random, the username to be guessed with ID appended, and the role to be guessed. By implementing the default trait, we now have a way to construct user instances with default values. One benefit of implementing the default trait on user is that we can use user anywhere where default implementations are required. For example, let's go back to main. The new function returns a result type, so to print user1 on line 6, we first have to check if user1 is a user instance or an error. There is, however, a useful method on the result enum called unwrap or default. If new returns the OK variant, then unwrap or default will return the user instance inside the OK variant. And if new returns the error variant, then unwrap or default will return a default instance of user. This method only works on types that implement the default trait. In this case, because the username passed in is testuser123, we should get the default instance of user. Let's run our program to check. As expected, we got default values for user. Let's change the username passed in slightly and rerun our program. This time we got a user instance with the username we passed in and the role set to creator. The default trait could be automatically implemented via the derive macro for structs whose fields all implement the default trait. For example, let's create a new struct called post, which represents a single blog post. The post struct has three fields: content, which is a string, tags, which is a vector of strings, and likes, which is an unsigned 32-bit integer. All of these types implement the default trait, so we could derive default for the post struct. We'll also derive debug so we can print post out with debug formatting. Let's create a default instance of post and print it out. First, we have to import post. Then we'll create a variable called post1 and print it out. Let's run our program to see what values we get. Content defaults to an empty string, tags default to an empty vector, and likes default to 0. The last thing I want to talk about is the derive-new crate. The derive-new crate allows you to implement the new constructor function for structs and enums using a derive macro. Let's see how this works by implementing new for the post struct. First, we'll add derive-new as a dependency. Then we'll import the new macro. And add new to the derive attribute. Finally, we'll customize the new constructor by adding attributes to the fields in post. On line 48, we're saying that when calling the new constructor function, tags should be set to a vector with one string, in this case, Rusty. And on line 50, we're saying that likes should be set to its default value. Let's create another post in main using the new constructor function. Notice that the new constructor function for post only takes one argument, which is called content. That's because tags and likes already have set values. Let's run our program to see what values we get for post 2. For post 2, content is set to example content, tags is set to a vector with one string, Rusty, and likes are set to 0. In summary, there's only one true constructor for structs and enums in Rust, which is to specify the name of the struct or enum and initialize all of its fields. However, there is a convention in Rust of adding a constructor function called new to your type. This gives you the ability to initialize private fields, set default values, and perform some work before creating a new instance. You can also use the derive-new crate to automatically implement the new constructor function by adding attributes to your struct or enum. Lastly, to get the functionality of a default constructor, you can implement the default trait for your type. Alright, that's it for this video. If you want to see more videos about idiomatic Rust, then leave a comment down below. If you like this video, make sure to give it a like, and make sure to get your free Rust cheat sheet by heading over to letsgetrusty.com/cheat sheet. And with that said, I'll see you in the next one.